What's up, Simony family? How are you guys doing? I hope it's great. I'm doing great because I'm doing chemistry. And if we're doing chemistry, we're doing great. Am I right? Nope. All right. I want to start this video by saying stop watching it if you haven't done this stuff yourself yet. You will not learn anything by watching this video and copying my answers onto your study guide. You will not learn anything. Okay, you have to try this stuff on your own. You have to make mistakes and then see those mistakes, correct those mistakes, and learn how to do it. So stop it. Stop it right now. You know who you are. I know you're watching this and you haven't done this yet. I know it.
Jeff, are you talking to yourself again?
No, I'm making a video.
Oh, my bad.
That's all right, man.
Carry on.
Thank you. All right, stop it. Stop watching it. Stop it right now if you haven't done this yet. Okay, let's talk about ionic compounds. All right, what kinds of atoms make up ionic compounds? So we just talked about covalent for a while, right? Covalent compounds are made up of nonmetals bonded together, sharing valence electrons. Ionic compounds are made up of nonmetals, or a nonmetal and a metal bonded together, okay? So one becomes a cation, one becomes an anion, and what holds them together is the electrostatic force of their opposite charges, okay? So positive charge and negative charge attracted to each other holds them together, okay? That's what holds together an ionic compound. One positive charge, one negative charge, and they're bonded together, okay? Let's move on to the next question. What forms cations, what form anions, and why do they do this, okay? So what forms cations? You have a nice thing in your notebooks that shows you this. Cations, whoa. Cations are formed by metals, okay? Anions are formed by nonmetals. All right, now why do they do this? Let's look at our periodic table here. Okay, I'll erase this stuff from the last video. All right, so if we draw a line here, okay, and a line here, okay, this group, starting with carbon, doesn't really form anions or cations because these all have 4 valence electrons. So it would take a lot for them to completely lose those or gain 4. So typically they just stay the way they are. They're not very reactive at all. All right, now if we're looking this way, now boron is a little bit of an exception. I talked about how boron's weird a little bit in the last video. However, aluminum is considered a metal because it has all the characteristics of a metal, even though technically it's in the metalloid ladder, it's considered a metal. So when we're looking this way, these atoms are going to lose their valence electrons, all of them, because aluminum, for example, right? I drew this in class. Let's do one that's actually easier to draw so I can do it quickly. Okay, if we're talking about magnesium, let me draw magnesium right here. Okay, magnesium. There's the nucleus. It's in the second group. Second group, the alkaline earth metals, so it has 2 valence electrons. And it's in the 3rd energy level, so it has 3 energy levels. So if this is the nucleus of the atom, here's 1, 2, 3. All right, now let's draw some electrons. 1s1, 1s2, 2s1, 2s2, 2p1, 2, 3, 4, 5, 2p6, 8 total in the 2nd energy level. Okay, and then the 3rd energy level, 1s1, 1s2, 2 valence electrons. Okay, magnesium wants to get to 8 valence electrons. So if we were to try to get 8 in its valence shell, it would have to gain 6. That's a lot. It would have to go over this way and have to gain 1, 2, 3, 4, 5, 6 to get to argon. But to get to neon, it just needs to go backwards 1, 2 and lose its 2 valence electrons. So that's what it does. It goes, I don't want this, and I want this. Now it has 8 in 2nd energy level. It lost 2 electrons, so it went from having 12 protons and 12 protons and electrons, okay, to having 12 protons and 10 electrons. Okay, so if that's the case, now it has 2 less electrons than protons, 2 more protons than electrons, 2 more positive charges than negative charges. So now it has a +2 charge total. Okay, so that's why the metals form cations. Cations are positive, we know this. They lose their electrons, and when they lose electrons, they lose negative charges. They now have a positive charge. I've said before that can be a little bit tricky to think of. They're losing something, therefore they have positive charge. but you have to think about what it is, how it's the number of protons and electrons. You kind of have to take a second and think about it. All right. Now, nonmetals gain electrons. So let's look at fluorine, for example. Okay, fluorine wants 8 valence electrons as well. It's just one away from neon. So it wants to get the same configuration magnesium just did, but it's going to do it by gaining 1 electron. So it has 7 valence electrons, and it's going to gain 1. I could draw that out here, but I think you get the idea. It gains 1 electron, therefore it has a -1 charge. It went from having 9 protons and 9 electrons to having 9 protons and 10 electrons. If it has 10 electrons, it has 1 more electron than proton. It has a -1 charge overall. Okay, so metals form cations, nonmetals form anions, and they do this to get 8 valence electrons. Most to get 8 valence electrons. Hydrogen is going to gain 1 to become helium. Okay, so that's what's going on there. You can review this in your notebooks further. That's how we get cations and anions. Now let's look at some ionic compounds and naming them. So let's just start at the top, potassium chloride. Now you'll notice in all of these with ionic compounds, we're not using the prefixes of mono, di, tri, etc. Okay, you just name them the names and add "ide" to the second one. That's all you do. And then you have to figure out how many of each one there are based on the charges they form. So the cation always comes first. So right here we have potassium chloride. All right, now let's figure out the charges. So we find potassium. I'll erase everything else that I already wrote earlier. Okay, so we're looking at potassium right here. All right, potassium's in the first group. It has 1 valence electron. It's going to lose that valence electron to go backwards to here to become argon. So it's losing 1 valence electron. It's going to have a +1 charge. You just represent that with a plus sign. Chlorine. Chlorine is a halogen. It's right here. It also wants to get the same configuration as argon. It's going to do that by gaining 1 electron. So it's going to have a -1 charge. Minus. Okay. Now to figure out the formula, you have to balance them. You have to have the appropriate number of cations, the appropriate number of anions, so that the overall charge on the molecule is 0, is neutral. Okay, and this is a pretty simple one. We have +1 and we have -1. So you just need 1 of each. It's a 1-to-1 ratio in order to balance them out. So the formula would just be KCl. So all it is, potassium chloride. Okay. Now the next one, we're given a formula. Okay, we're given MgN, magnesium nitrogen. Okay, so to name it, first of all, the first name stays the same, magnesium. Remember I said in class, the first name is the name of the cation. Cations are positive, they stay the same. They have positive attitude, they have positive energy, okay, positive charge, positive energy, they stay the same no matter what. Anions are negative. A negative ion, An ion, A negative ion, anions. They're negative. They're always like, I'd rather be doing this, I'd rather be doing that, I don't like where I am, I'd rather be doing something different. They can't just love where they are because they're so negative. Okay, so nitrogen negative, I'd rather be doing something else, nitride, ide. You change the suffix to ide. So magnesium nitride. So here we're dealing with magnesium, which is going to want to go back to neon here. Okay, it's going to do that by losing 1, 2 valence electrons, so it's going to have a +2 charge. I think I just noticed a mistake with this question I asked here. Okay, then we have nitrogen, or maybe I made a mistake in how I copied it. Yeah, I think I might have made a mistake in how I copied this. Either if it says MgN on your study guide, then I made a mistake on the study guide itself. You'll notice I had to handwrite this chart in. For some reason, it wouldn't copy and paste. So maybe I made a mistake there. I don't know. But, okay. N, all right, nitrogen to get to neon needs to gain 1, 2, 3 electrons. Okay, it's gaining 3 electrons. It's going to have a -3 charge. Okay, so if you notice a mistake here, then you're ahead of the game. Because this formula is wrong. Why is it wrong? Because if I just have 1 magnesium and 1 nitrogen, I'm going to have a 2+ charge and a -3 charge. It's not going to balance out. It is not going to balance out. There's going to be an overall -1 charge because I have +2 and I have -3. 2 are going to balance each other out, and then I'm left with -3. Okay? That doesn't work. So what do? We criss them, cross them, it's going to be awesome. The value of the charge, not the charge itself goes away when we're talking about subscript because that's just number of atoms. The value of the charge alone, criss them, cross them, it's going to be awesome. Make it the subscript of the other one. So a 3 should come down here and a 2 should come down here. All right? Because 2 times 3 is 6. You have 2 nitrogens, you're going to have a total of a -6 charge. 3 times 2 is 6. You're going to have a total of 3 magnesiums. They're going to be +6 charge. They balance each other out. So that's the ratio you need to get a balanced formula. Again, if I messed that up on your study guide, I'm sorry. I must have had a lapse of whatever when I was writing it, or I messed up copying it. Either way, if you caught that, great job. I did it on purpose to give you the opportunity to catch a mistake because that helps you learn. All right, let's move on. Sodium phosphide. So sodium, we know we have, I'm going to go back to blue. Okay, we have sodium here, Na. Is that a different color? Yeah, it is. Whatever. Sodium, and then phosphide is phosphorus with the "ide" ending because it's an anion. Okay, so let's look at our periodic table. Sodium, right here. It's an alkali metal, first group. It has 1 valence electron to lose, so it loses that valence electron and gets a +1 charge. Phosphorus, over here, group 5A, it has 5 valence electrons. It's going to gain 1, 2, 3 to get to 8. So this has a -3 charge. Now we need to figure out the formula, okay? So we have +1 and -3. A couple different ways you can do this. Okay, you can criss them, cross them, it's going to be awesome. Okay, you can just look at it and think about what needs to balance it, stuff like that. So if we just put it together like this, NaP, all right, you're going to have +1 and -3, so it's not balancing out. Okay, so how many +1s do you need to balance out a -3? How many sodiums do you need to balance out 1 phosphorus? Well, you need 3 of them. And if you criss them, cross them, crisscross method, this +1 comes down here, then you get Na3P1. All right, so you need 3 sodiums, 3 positive charges, 1, 2, 3, to balance out 1 -3 charge. Okay, it's all about balancing out the charges so that it's neutral. All right, now let's get into some transition metals. So here you have iron chloride. I just gave away the name, but iron chloride. However, since we're dealing with a transition metal, we're not done with that. Okay, so iron is right here. Where it is on the periodic table doesn't matter because transition metals can form multiple different cations. Okay, they have a weird amount of valence electrons. You'll remember that this is the D group here, so that changes things with how many valence electrons it has. Everything's a little bit funky, but it's okay because all you need to worry about is what the charge is going to be. And in a case like this, you figure it out from what the anion is and the number of each you have. So this is a 1-to-1 ratio. So we know that whatever the charge is on this chlorine is balanced out by 1 iron. So let's find chlorine. Chlorine's right here. We already worked with chlorine in this exercise. It's gaining 1 electron. So chlorine is going to be a +1 ion. And that's balanced by 1 iron. If it's balanced by 1 iron, I'm sorry. Hopefully you caught that as well. Chlorine's gaining 1 electron, so what's it going to be? -1. -1, not +1, okay? Chlorine gaining 1 electron, -1. So it's -1, and 1 chlorine, 1 minus charge is balanced by 1 iron. So it's a 1-to-1 ratio. What's it going to be? If it were +2, then it wouldn't be balanced. We'd have an overall +1 charge. So it has to be just +1. Okay? If it's just +1, we represent the value of the charge with a Roman numeral. Okay? So +1 would just be 1. Roman numeral 1 is 1I. Okay? So iron 1, chloride. Roman numeral tells us the value of the cation charge. Now let's keep that in mind when we go down here. Here we have vanadium 3. Vanadium is right here. Again, doesn't matter for the charge. It's just if you need the symbol, if you don't know it, it's down here. So vanadium is V. The 3 right here, the Roman numeral 3 tells us it's going to be +3. Okay, that tells us our the value of our positive charge. It's always a positive charge. Transition metals are always forming cations because they're metals. Like we said here, metals form cations. The Roman numeral tells us the value of that charge, which can vary. Now here we have nitride. So our anion's nitrogen. We worked with nitrogen before. Here it is. It's going to gain 1, 2, 3 to get to neon, the configuration of neon. So it's -3. Nice and easy here. We have +3 and -3. So it's going to be a 1-to-1 ratio. That's all it is. Some of you were putting 3s down here, but if you have a 3 and a 3, you can simplify that to 1 and 1. If it's 1 and 1, you don't put anything. Okay? So that's all you need to put. Some of these were pretty simple. If this was vanadium +2, if it was just a 2, oh, I guess that works. If it was just a 2 here and you had a 2 here, then you'd have to crisscross them and we'd have V3 and 2, stuff like that. I kind of wish I had given you one that was a little trickier for the ratio for those, but hopefully that makes sense to you guys. You have some more examples in your notebook of different ones. So make sure you know when you see something that's made up of a non-metal and a metal, it's an ionic compound. It's important that you can look at just a formula and identify what's a covalent compound and what's an ionic compound. Once you figure that out, you can name it. Ionic compounds, you don't use prefixes. You just name them the cation and the anion with an "ide" suffix. Then you can figure out the formula from the charges that you figure out from the periodic table. Okay? So hopefully that clears that up or helps explain it or just confirmed that you already knew what you were doing. Smash that like button, hit subscribe. Any questions at all, leave me a comment down below and I will get to them or comment on it in another video. All I got to do now is wrap up the polyatomic, maybe do a little overall review, and then you guys should be good to go to study for this test, which is going to be a big one, big opportunity for success.